Here we are with exercises 4 through 7. I'll just do the rest of the exercises here for you. Exercise 4 is a really important one to do yourself. I'll give you a little bit of a hint if you're stuck here with the first one. After I've explained the first one, you should definitely do the rest of them by yourself as much as you can, because it's really important practice. So I'm going to start with plugging in 0 here. So when x is 0, this is going to become y equals 2 times 3 to the power 0. And 3 to the power 0 is just 1. So this is 2 times 1, which is just 2. And that makes sense. This agrees with what we were talking about before, that number 2 is the initial value of this. So that's what you get when x is 0. Now here for the 1, we're going to get y is equal to 2 times 3 to the power 1, which is just 2 times 3, which is 6. And this agrees with the fact that 3 is the growth factor. To go from 2 to 6, you multiply by 3. And here we want to multiply by 3 as well. So we're going to do, if you multiply this by 3, you'll just do 6 times 3 is 18. You could also get that by plugging in 2 into the formula and do 2 times 3 squared. 18? Did I say 18? I wrote down 16. Anyways, 2 times 9, if you do it this way, gives you 18 as well. Okay, so now to fill in these, you could approach this a couple ways with negative numbers. You could think, what could I put here so I multiply it by 3 and get 2? What can you multiply by 3 and get 2? How about 2/3 times 3 is 2? That will work. You could also get that by just plugging in -1 into the formula. You'll get y equals 2 times 3 to the power -1. And what does 3 to the -1 mean? It means 2 times 1/3, which is also known as 2/3. And same deal with the -2. If you want to plug that in, you'll get y equals 2 times 3 to the power -2. And 3 to the power -2 is 1 over 3 to the power 2, which is 1/9. So you have 2 times 1 over 9, which gives you 2 over 9. And if you want to check that, you could get that by multiplying 2/9 times 3. 2/9 times 3 does turn into 2/3. So yeah, it all works out. Sounds good. So now these points, I'm going to have to label the x-axis here. Maybe I want this to be 2. You could label it a different way. If that's 2, this is 1. This is 3, 4, 5, 6, 7, 8, 9, 10. And we'll get the points we have. We have 0, 2, x equals 0, y is 2 is right there. X equals 1, y equals 6 is right here. X equals 2, y equals 18 is somewhere off the top, I don't know, around here or something. And it's okay if you don't actually fit all of the points here. Anyways, and then we have -1 2/3. So this is 1 here. So 2/3 is a bit less than 1. That's going to be about that y coordinate. And then -2 2/9, that's pretty close to 0. That's more like this. All right, so if we fill in the points between the lines with a nice smooth curve, we should get something that looks kind of like this. And yeah, if you didn't have your y equals 18 fitting on the graph, just try to draw your graph kind of going towards that point up there. All right, so that's that one. The next ones I'm going to do a little bit quicker just to make it easier for you to check your answers. without having to listen to the whole explanation, because you should definitely be doing these on your own. So this is going to be 200, which is the initial value. If we multiply that by 0.5, we'll get 100. Another 0.5 makes that 50. This will end up being 400 and 800. And those points, let's see. I'll make this be 100 here. And again, if you labeled your y-axis differently, that's fine. As long as it's evenly spaced here. Wait. 0, 200, 1, 100, and 2, 50. -2, 800 is somewhere up here. So should look something like that. So you can see when you have b equals 0.5, you get something that is decreasing, because 0.5 is less than 1. Every time you multiply by 0.5, it makes it smaller. So this makes it, we can say that y decreases as x increases. There's something to notice here. As x goes to the right, y goes down. Okay, let's look at b here. We have 5 times 2 to the power x. This is going to give you 5, 10, and 20, 2.5 and 1.25 over here. So make this be 20. We'll go up by 4 this time. Again, if you want to label this differently, that's okay, as long as each tick mark is evenly spaced apart. So 0, 5 is going to be about here. 110 is about here. 220 is right here. And then there's -1, 2.5 is right here. -2, 1.25 is about here. There we go. Let's get D here. This is going to start at 270. That's the initial value. The growth factor is 1/3, so this is going to go down by 1/3, which is going to give you 90. 1/3 of that is 30. And this is going to be multiplied by 3 if we go backwards, which is going to be 810. That times another 3 is going to be 2,430. I'm going to make this 200 for each tick mark on the y-axis. So that would be 400. So if it's starting at 270, that's a little bit closer to 200 than to 400. And then we have 190 is about here. 230 is about there. -1, 810. Should be right about here. Then -2, 2,430 isn't going to fit here. It's going to be way off the top, and that's okay. We're just going to draw the graph kind of going towards that. And there we go. All right, so that's the way exponential functions look when you graph them. The point of this exercise was to connect the arithmetic that you do when you plug in values of x to the y coordinates that you get out and see how that gives you a certain shape of the graph. So let's try to fill in these blanks using the evidence from these graphs. And again, if you haven't done this yet, let's do it now. I'll give you a moment to think about what should go in these blanks. Okay, if you've paused it and filled them in with a guess, here's the answers. They all have y-intercept 0, a. So, for example, when this one has a is 5, we get the point 0, 5, which shows up as the y-intercept. Here we have 0, 270, that shows up as the y-intercept there. Same thing here, we got 0, 2, when a is equal to 2, when a is equal to 200, that's your y-intercept there. Now, what about the x-intercept? Where are these graphs crossing the x-axis? It doesn't look like any of them are crossing the x-axis. It looks like sometimes you might get a pretty small fraction, like something close to 0 for your y-coordinate, but we're never actually getting a y-coordinate of exactly 0. So it looks like they have no x-intercepts. So let's see. Which of these have y increasing as x increases? Part B does. And part A does as well. So what do these have in common? And what's the difference between those and the decreasing one? Here we have a decreasing y over here. And here we have a decreasing y here. Well, the difference is, what are you doing every time x increases here? You're multiplying by 2. Multiplying something by 2 makes it bigger. It makes it increase. Over here, every time x increases, you're multiplying by 1/3, which makes it smaller. So the ones that are increasing are the ones where the b, like the 2 or the 3 here, where b is greater than 1. Multiplying something by a number greater than 1 makes it increase. What about the ones that are decreasing? Over here you're multiplying by 0.5. Here you're multiplying by 1/3. That makes it smaller. So it's decreasing if b is less than 1. Okay, so those are some important properties that you should know about graphs. And remember, anything that's in a box like this is something you need to know. You might want to make flashcards about this to help quiz yourself to memorize it. I think that's a really good way to memorize stuff. Another way to learn this is to just sort of keep thinking about it as you're working on stuff. Make sure that when you're doing the homework, that the answers that you get agree with what you have in these notes. If you're going the flashcard route, you could have something like have one side of the flashcard say the y-intercept of y equals a times b to the x, and then on the back side of that card say something like 0a to help you remember that. You could also say on another flashcard, y equals a times b to the x has y increasing if blank, and then on the back side of that card you can have b is greater than 0. That's a good way to memorize important stuff like this. Okay, so let's look at the answers to exercise 6 next. If p equals f of t equals 10,000 times 1.025 to the power t, and that gives the population of a town. So the result of this, p, is the population of the town, where t is the number of years after 2005. let's evaluate each expression and say what it says about the town. So f of 0, we're going to get by replacing the t here with 0. So it's going to be 10,000 times 1.025 to the power 0. And anything to the power 0 is 1. So this just gives you 10,000 times 1, which is just 10,000. So what does that tell you about the town? That is the population of the town 0 years after 2005. Because that's what t represents, is the number of years after 2005. And the result that we get is this population. So that tells you the population in 2005. We should say was 10,000, I guess. This is in the past. Okay, what about f of 1? We're going to do 10,000 times 1.025 to the power 1. That's going to be, let's see, 10,250, I believe. And that tells you the population 1 year after 2005, which is in 2006. Okay, now exercise 7 is a challenge. These ones are optional. I recommend trying it if you're trying to get an A in this class. If you're struggling with the math, if you're like, hoping to scrape by for a C, or maybe a B if you're lucky, then you might do better spending your time to really focus on the more basic exercises and make sure you really understand those. These are kind of more advanced things that you might be banging your head against the wall if you're struggling here. So, but I'll show you these answers if you are giving yourself a challenge. And let's see. So which ones are exponential? And if so, identify A and B. So the trick here is this can be written as 4 times 4 to the power negative t. That's what a negative exponent means. And that, right now, it's not exactly exponential. Like, we want it to be a times b to the power t. And this doesn't just have the power t, it has the power negative t. So there's a trick, is we can write this as 4 times 4 to the negative 1, and that to the power t. Because a power to a power, they get multiplied to become negative t. But right now, yeah, you can see that it is exponential if it's written as 4 to the negative 1 to the power t. So this one is, the A is 4, and the B is 4 to the negative 1, also known as 1/4. Yeah, you could also write this as 4 times 1/4 to the power t. All right, so this one is also a little weird. We still have the negative t, and there's also the divided by 3. And the trick with the divided by 3 is you can write this as 1/3 times 2 to the negative t. That way we have it as multiplication, which is what we want because the formula has a times b to the t. This now has a number times something to a power. So that's part of it. But then we still have the negative t problem. So I'm going to write that as, like the same trick as before, 2 to the negative 1, and then that to the t. And you could also write this 2 to the negative 1 is the same thing as 1 divided by 2 to the 1, like so. So this is another equivalent way of writing that. So yeah, this is exponential. The a is 1/3, the b is 1/2, and you could also write that as 2 to the negative 1, same deal. How about q? Well, the formula for an exponential function here doesn't have a square root in it. So we want to try to write that as an exponent. And the way to write a square root as an exponent is as an exponent of 1/2. That's the same thing as a square root. So now what can you do with that? Well, if you have two things being multiplied on the inside here, all raised to a power, one of the exponent rules from chapter G, a lot of those exponent rules are going to be important in chapter 6. So one of them is that this is the same as 5 to the power 1/2 times 4 to the power t to the 1/2. And you can just write that as 4 to the power 1/2 t. Okay, now 4 to the power 1/2 t, you could write that as 4 to the power 1/2, and then that to the power t. And 4 to the power 1/2 is the square root of 4. And the square root of 4 is just 2. And same thing with the 5 to the 1/2. You can write that as the square root of 5 if you want. It doesn't matter. So yeah, this is exponential. The a is either 5 to the 1/2, or you could write it as the square root of 5, same thing. And the b is 2. Or you could write it as 4 to the power 1/2 if you want. Okay, so let's look at D now. Again, we want to try to write this as Q equals A times B to the T. And, all right, so we could take the square root of 5 and the square root of T to the 4th separately, just like before. And the square root of T to the 4th is T squared. And the problem here is that the t is the base of the exponent. The variable is the base of the exponent, but it's supposed to be the exponent itself. So this is not exponential. This is a power function, specifically a quadratic function. So the graph is going to be like a parabola, not like the graphs that we looked at in exercise 4 here. All right, a couple more here. These are getting extra tricky the further we go on. So let's see, we can do 27 to the 1/3. And we can do that times 8 to the 1/3, and also t to the power 6 to the 1/3. And the exponent 1/3 is the same as a cube root. So the cube root of 27 is just 3. The cube root of 8 is just 2. The cube root of t to the 6th is just t squared, that you could also get by multiplying 6 times 1/3. So this is going to turn into just q equals 3 times 2 is 6 times t squared. And this has the same problem as before. This is a power function. Okay, so the base of the exponent is the variable instead of the variable being the exponent. Let's try f. F is a kind of a weird one. So, we could take the square roots of the tops and bottoms separately. And well, I'm not sure what the easiest way to do this is. I'm gonna write it as a square root here of 10 to the 2t in the top divided by a square root of 4 to the t in the bottom. Now, how can you take the square roots of these things? Well, I'm going to write the 10 to the power 2t as 10 to the power t all squared, because t times 2 is 10. And the reason is that now you can make the exponential thing cancel out with a square root. So, and then the bottom, the 4, I'm going to write that as 2 squared. So 2 squared to the power t is 2 to the power 2t. And in the top, the square root of something squared just cancels out to give you 10 to the power t. In the bottom, I'm going to do one more step here to write that as the square root of 2 to the power t, and then that's being squared. That will cancel out to give you just 2 to the power t. So we end up with 10 to the power t in the top divided by 2 to the power t in the bottom. And if these are both to the power t, we can write it as 10 over 2 to the power t, which is just 5. And you could also write it with a 1 in front, just so that you can see that the value of a in this exponential function is 1. And the b is 5. So if you got this one, if you got f on your own, you are probably one of the few people in the class to be able to do that on your own. Give yourself a large pat on the back. And if you didn't get it, that's okay. These are extra hard challenge problems, and it's okay to not get them. But whoever you are, the best time to work on the 6.1 homework is today, because 6.2 is going to rely on you understanding the basics of 6.1. And it's like building up a pyramid here. You got to have a strong foundation. So that will help you a lot more with that tomorrow. All right, good luck, and I'll see you in the next video.